expect a question from conduction and radiation. So that's why I said today's class is going to be important. Even if you are like not minding the boards, not minding the 11th school exam and believing the school that anyhow they are going to pass you, even in that scenario, what is important is this chapter for NEET or JEE. So you will see, if you see last 10 years questions of NEET or JEE, you will find questions coming from conduction especially and a bit of questions from radiation. Radiation is a topic which if you don't understand, it can be very confusing. I have seen children leaving radiation topic itself because they fail to understand it better. But it is a very interesting topic, little complicated I agree, but it is very interesting if you are able to understand how it works. So my aim today is to make you aware, to make you clear, to make you strong in conduction, convection, radiation, which are the modes of heat transfer. Before I start with today's class, I will take 2-3 minutes of time to recall what all things we have learned in this chapter already. So in this chapter, we learned about thermometry and calorimetry already. The first day when I started this topic, I focused on thermometry, where we focus on measurement of heat, not heat, measurement of temperature, sorry. So where we saw there are different scales of temperature, which were Kelvin scale, degree Celsius scale, degree Fahrenheit scale, and we learned how to convert one scale to another scale. Degree Celsius to Fahrenheit, Fahrenheit to Kelvin, Kelvin to degree Fahrenheit, all these things you understood now. If you were there in the class, if you were listening properly, then by now you know how to convert one temperature into some other temperature scale. That I have taught you. I taught you the fundamentals of temperature conversion. That is, you should know the lower fixed point, you should know the upper fixed point, and you should know the number of divisions. In the case of Celsius scale, lower fixed point is 0 degrees, upper fixed point is 100 degrees. Lower fixed point means the freezing point of water, upper fixed point means the boiling point of water. In terms of Kelvin, it is 273 Kelvin as lower fixed point and 373 Kelvin as higher fixed point, upper fixed point. In case of degree Fahrenheit, the lower fixed point is 32 degree Fahrenheit and upper fixed point is 212 degree Fahrenheit. So if you see, the number of divisions in the degree Celsius is 100, Kelvin is 100 and Fahrenheit scale is 180. If you know this, you can convert any temperature into any other scale of temperature, isn't it? So after that we learnt about calorimetry, and calorimetry is fully based upon the principle that whatever heat is lost by one body will be always equal to the heat gained by another body. That is, I gave the example like if you are having a fever and you touch something, you feel it is very cold, isn't it? During fever we get a desire to touch the walls and all these things because our body is hot. When you touch a wall, it seems cool to you because the heat is transferred from your body into that wall that you are touching, the tile that you are touching. So heat is lost from your body, that's why you are feeling it is cold. At the same time, if you touch something that is hot, why you feel it is hot? Because heat is entering your body. So if heat enters a body, it feels hot. If heat exits from you, you feel it is cold. So as simple as it is. Nothing is hot, nothing is cold. Everything is relatively hot and relatively cold. I gave an example to you that even if you are at 100 degrees temperature, 1 or 2 degree temperature, 102 degree temperature person, if he or she is touching 104 degree temperature person, then he will say that it is hot. But 104 degree person, if he touches the 102 degree person, he or she will say he or she is cool. But for a normal person who is at 98.4 degree Fahrenheit, it looks both of them are having fever. Reason being, if you are at 98.4 degree, then the heat will be coming to your body from their body, and so you feel it is hot. And when a person who is at 104 degree is touching 102 degree, heat will travel from his body to 102 degree body, you feel it is cold. Then I talked about specific heat to you, where specific heat MC delta T, latent heat MLF and MLV, where MLF is the latent heat of fusion and MLV is the latent heat of vaporization. We talked about all these things in the previous class, isn't it? And we did numericals based upon that to make you understand how it works. That is, if you add ice in water, how the ice is melted. We have to find all the energy. So all these of things, whatever I have spoken in the last few minutes, we have discussed till now. Today's class, we are going to focus on modes of heat transfer, which is not new for you. You would have definitely studied this topic in the 8th physics or maybe in the 9th chemistry somewhere. It should not be a new topic for you. Conduction, convection, radiation is quite known topic to you as far as my knowledge is concerned. Anyhow, even if you don't know, we will recall it once again, right? So if heat gets transferred from one body to another body, it can get transferred by 3 different means: conduction, convection and radiation. How are these 3 different from each other? So anybody who can tell me what is conduction, what is convection, what is radiation? Please.
Conduction in solids,
Okay.
convection in liquids, and radiation in gaseous.
Oh, so Anshul says that conduction happens
Sir,
in.
can I add some more points?
You can add, man.
Radiation
I'll give chance to you. Yes, Anshul, please tell.
if I'm sure, radiation is also possible in solids and liquids. I guess.
Okay, so he now he says that conduction happens in solids, convection happens in liquids, and radiation can happen in anything: solid, liquid, gas, anything. Yes, Pratap, please comment something if you want to.
Yes, sir. Basically, conduction is solids and in which the movement of molecules of matter cannot be observed.
Hmm.
One such example is that if we have two hot vessels next to each other, the colder one tends to get hot.
Hmm.
And convection is generally observed in fluids, and
Hmm.
it also occurs in bulk values, like example boiling of water, like the lower bulk first gets hot first,
Hmm.
and then the the phenomena continues to be in a bulk process,
Hmm.
and radiation does not require a medium like conduction or convection.
Okay. So Anshul and Pavitra, your videos are off. Yes. Nitish, you want to add some points in this if you have any idea? First time you're hearing about this conduction convection word?
Yes, sir.
Oh, good escape. Anybody else sitting in the offline class? Anything you want to add in this? No idea? Okay, let me tell you. So I'll correct all of you who have told the answer, that is Anshul and Pratap. Where you are wrong, I'll be trying to correct you. Okay. So first of all, don't try to think about conduction, convection, radiation in terms of solid, liquid, gases. First, you have to try to understand what is the meaning of the word conduction, what is the meaning of the word convection, and what is the meaning of the word radiation. Conduction is that mode of heat transfer where the heat gets transferred without the actual motion of the particles. Only energy gets transferred, particles will not get transferred. For example, if your mom is cooking something in the kadai or maybe in any vessel, and she is having one spatula in her hand. In Tamil we say it as karandi, right? So the karandi or maybe that spatula that your mother is using to make the food, in a few minutes that karandi becomes hot, am I right? Why it becomes hot? Because heat has travelled from the food, the vessel, to that spatula, am I right? Now when the heat transferred from that vessel to that spatula, don't think that the particles travelled. What would have happened? The part of the spatula near to the fire, near to the heat, that point the particles started vibrating more faster because of getting more energy. That particle hitted the nearby particle. It also vibrated. Once again nearby, vibration, nearby, vibration, nearby, vibration. So one particular particle is just vibrating in its place, but while vibrating, it hits the next particle. Now this particle starts vibrating in its place. Again while vibrating, it hits the next particle. Like that way, particle to particle, particle to particle, particle to particle, heat gets transferred. But the particle is not going to get transferred. It is only going to vibrate in its own place. Generally, as you said, it is seen in solids. Like I give the example now. Convection, on other hand, obviously some of you told, and it is true, generally observed in liquids and fluids, I should say, not liquids, fluids. In this convection phenomena, the heat gets transferred by the actual transfer of molecules. For example, if you would have seen your, again, mother cooking in the kitchen, and if she is putting water on boil, and if she keeps the water on the stove, then you may see that water is undergoing some motion. If you have not felt it, you can try it today itself. If you keep some container and keep on the stove, when the stove is off, the water will be very silent, no movement on the water. I am not talking about the bubbles forming. I am talking about you can literally feel that water is moving. Why water starts moving? Because when we heat, the lower part of the water becomes hot first, since it is in near contact with the fire. And if it becomes hot, it travels above, because it becomes less denser. And when the denser water, which is cold, comes down, once again the hot water goes up, cold water comes down, hot water goes up, cold water comes down. This process keeps on repeating until all of the water is hot. Am I clear? The water keeps on moving until all of the water is hot. One person is in waiting room. I hope you are getting my point. So, first the lower part of the water becomes hot, goes up, then hotter water up, cold water will come down. This process is called as convection. So, in convection, water, molecules itself moved up and down, up and down, up and down. This phenomenon is called as convection. So, how should you remember convection? Convection is a phenomena where the heat transfer takes place with the actual transfer of molecules. In the case of conduction, heat transfer took place without the actual transfer of molecules, only the energy got transferred. But in the case of convection, the energy gets transferred along with the molecules. I hope I am clear. Are you able to understand this? Whatever I have told now? Next, the third one and the most interesting one is radiation. Now, radiation is heat getting transferred from source to target without heating the intervening medium. That is, sun is there, right? Very hot, do you agree? Very hot. And when the sunlight is coming to the earth, earth becomes hot. Am I right? But if you go anywhere in the space, will it be hot? Between sun and earth, will it be hot? It will be super cool. You know this? Sun, super hot. Wherever the sunrise is falling, becomes hot. But intervening medium is cool. How? I'll give an example to you while with this diagram. So, if you see, there is a fire, right? So, I have shown three things in the same diagram where you can see conduction, convection and radiation taking place. So, for conduction I have drawn a rod in the person's hand and the heat is getting transferred molecule to molecule, molecule to molecule, molecule to molecule, with the only heat is transferred, particles not gets transferred. I have put the hands of the person above the fire, which is convection, because the hot air is rising up, he is able to feel that warmth of the hot air. Generally we do this, if you are in a cold place, we burn fire, we call it as, what we call it as? Campfire, yes, campfire. We do campfire and we put our hands above if it is too cold. Why we put our hands directly above? Because that part will be more hot. Why it will be more hot? Because hot air is rising up and you are putting the hand there where the hot water is rising up. Third thing, if you see, it is also true that if somebody is sitting little away from it, he will also feel some warmth, right? But the medium may not be warm. This body became warm, fire is hot, but the intervening medium, if you put thermometer and check there, it won't show any heat difference. Now, why does it take place? Today we are going to understand that. Not only that, have you ever seen the sky? Usually, see, we are in Chennai, highly polluted. I mean, don't compare with Delhi or other states. It is anyhow, compare with South Tamil Nadu, yeah, we are in pollution only, right? So, the problem with pollution is you cannot see stars well. You know this. Earlier, think about, I mean, you would not seen the time itself. If you are sleeping on a terrace, you can see the whole sky, very beautiful, all the stars. Nowadays, in a year, 10 days only you can see like that. Most days you will not see stars or you will see a few stars. Very rarely you can see a sky full with stars. But if you go to your village, maybe native, if it is somewhere in Tiruchendur or Tirunelveli or maybe Kanyakumari or Nagarkoil or somewhere down, and village, no much vehicles are there, less pollution. Then you see the sky, it will look beautiful, where you can see lot of stars in the sky, right? So it is very difficult for today's children to talk about the sky because, as I said, it's not visible much. But if you see the stars, whether all the stars are of same color, imagine you seeing the sky, and for better view you can go to Ladakh and see. If you go to Ladakh, you'll have very good view. Sometimes we can see even Milky Way from Ladakh. If you go to some hilly place, you can see a very beautiful sky. If you are able to see a very beautiful sky which is having all kinds of stars visible, do you think that all the stars will be of same color? Usually we think it is what color? Blue color, white color, yellow color, red color. Which color? Huh? Green color. Oh my God, you have seen green color sky, green color star. You have drawn by yourself by using crayons, or really you have seen? Sky is green. That you are talking about northern lights, I think. Aurora. I am not talking about that. I am talking about stars color. Stars are of various colors, I agree with you. So if I see two stars, one is red, kind of reddish, yellowish. One is blue. Can you say which is hot, which is cold? Relatively.
Blue is hotter.
Blue is hotter,
Red is cold.
red is cold. Okay. But we generally denote red with red for more hot and blue for more cold, no? Generally if you have a switch, one is red, one is blue, your mind will think red will give me hot water, blue will give me cold water. Am I right, Mr. Sai Akhilesh?
Yes, sir.
But in this case you are saying that red star is cooler and blue star is hotter. Am I right, Sai Akhilesh?
Yes, sir.
Can you justify why?
Star in short, sir.
Okay, you saw in shorts somewhere that red.
Right.
Please, you can try. Give a try. No issues. Good.
Sir, the visible spectra to the human eye is red, yellow, and some very little kind of blue, I think.
Okay.
I'm not so sure about this.
Okay, please try. Yeah.
After the stars reach a higher, the temperature where the light cannot reach,
Okay.
we'll see kind of a whitish and bluish color.
Okay.
And the red color is the color that is visible to the human eye.
Okay.
So, which has lesser temperature and which can capture red light is visible to our eyes in red color.
Okay. So you are saying that blue or white we cannot see, human eyes cannot see.
No, sir, because the stars are actually not blue or white in color. They might be in a different color, but which will not be visible to the human eye. So we tend to observe it as white or blue.
Okay. Now my question to you is, I am seeing three stars. One is red, one is blue, one is white. Can you tell me the temperature difference between them? Who is hotter, who is cold, and who is in the middle? Can you tell me? Pratap, can you give a try?
Yes, sir. I think the white will be the hottest, the
Okay.
blue will be the middle one, and the red will be the cold.
Sai Akhilesh, you agree with what Pratap has told? He says,
I have no idea, sir. I think the blue will be the hottest, sir.
okay, and white will be in the middle,
Yes, sir.
and red will be the lowest.
Yes, sir.
Okay. Today's class, if you are there in the class till the end, I am telling not in the terms of attendance, I am telling in terms of your acceptance by brain. Then by today's class end, you will be able to understand all these things clearly. And this question comes in NEET exam also. I can show you a question paper, last 2-3 years back paper, where they've asked directly this question only, that there are two stars in the sky, blue and red, which is more hotter, and why. Why means not like that way, some explanation with 4 options. So today's class, that's why I said it is very important. Okay. So we'll come to that radiation at the last. Before that, let us first talk about conduction. So what is conduction? Start writing now, please, all of you. So what is conduction? It is a mechanism of transfer of heat between two adjacent parts of the body because of their temperature difference, and in this case the actual particles never moves, only the heat gets transferred. So all of you can take the notes, write the definition of conduction as, it is a mechanism of transfer of heat between two adjacent parts of the body without the actual transfer of the molecules. Everybody, I hope you are writing. Please write properly. So conduction is a phenomena where there is a transfer of heat taking place without the actual transfer of particles, right? So you can see I have drawn another diagram where I am showing that when there is a burner burning, then it heats the molecules near to it. It starts vibrating the next molecule, again next molecule, again next molecule, and slowly the whole heat gets transferred. If you see the diagram, you will realize it. See for a second, you can see that there is a transfer of heat taking place. I am once again doing it. See, initially the heat started flowing from left towards right. You see, slowly the heat is moving. Can you feel? Heat is moving, yes, moving, 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 it reached the last. But the particle, this particle remained here only, this particle remained here only, this particle remained here only. But what got transferred? The heat energy got transferred. That is only conduction. Energy gets transferred, molecules will just vibrate in the same place. But by the vibration itself, it is transferring the energy to the nearby molecule. Right? Simple? Fine. Then let us try to derive the formula of rate of heat transfer. Okay. So for that, I have drawn two bodies here, body A and body B. One body is at higher temperature, one body is at lower temperature. As general normal people, I am representing red for hotter body and blue for colder body. So this body is at higher temperature, blue is at lower temperature. So the heat transfer will take place from where to where? Always from hot to cold. So I am connecting it with a rod, and I am taking the length of the rod as L, and generally we are using some insulation for avoiding the loss of heat, right? So what is going to happen when you are going to do this connection? Within a few minutes or few seconds, this body will start getting hot, isn't it? Because the heat will get transferred from where to where? From body A to body B, and since I am using some good insulation, I will not have much heat lost in the environment. So after a few time, you will see this will become red or it will become hot. Now when this is happening, we are interested in finding what is the rate of heat transfer. That's what our aim is. So you can see here, slowly the heat is getting transferred, and then this blue body will slowly start becoming red, and the heat got transferred. Both bodies came at same temperature after some time. Am I right? So now the thing is, what factors it depends? What depends? Rate of heat flow. I have mentioned it as H. Rate of heat flow is mentioned at H. What is the meaning of that? H means Q by T. Q is energy, T is time. Rate means divided by time. So H, which is equal to Q by T, is proportional to three things. Please pay attention. One is temperature difference, delta T. Another one is area of cross section. I am writing it as A. And third one is length. So heat transferred time is proportional to temperature difference, proportional to area of cross section, and is inversely proportional to length. Clearly visible and clearly understandable. If you have more length, it will take more time for the heat to move, isn't it? And if you have a shorter length, it will go more quickly. So it's inversely proportional. Will be more late, shorter, will be more quicker. Second is temperature difference. So suppose this body is at 100 degree, this body is at 40 degree. In second case, 100 degree and 90 degree. So in the case when the temperature difference is big, then the rate will also be fast. It will go very fastly. If something is very hot and very cold, immediately the rate, I am talking about the rate, understand that. It means how fast or how slow. So the more hot the temperature difference between the object is, the more faster the heat gets transferred. If the temperature difference is less, the rate will also be less. And third thing is area of cross section. We found that if there is a more area of cross section, it will have more heat transfer, more rate of heat transfer, and lesser cross sectional area will have lesser rate of heat transfer. So if I put all these things in the numerical terms, what I am going to get, you see, I am going to get H is proportional to A into TA minus TB or T1 minus T2, whatever you want to write, T1 minus T2 by L. And when I remove proportionality, I have to write a constant K. This K has a name. K is called as coefficient, thermal conductivity of material. Thermal conductivity or coefficient of thermal conductivity, both you can write. Either you can write coefficient of thermal conductivity or you can write thermal conductivity of the material. So we got the formula Q by T, which is also called as H, is equal to K times A into delta T by L, the length. This is the formula of heat energy transferred per unit time. H is Q by T. H is what? Rate of heat transfer. Never forget this. H is rate of heat transfer. If they ask you to find what is the amount of heat transfer Q, then it will become K into A into delta T into small t by length, isn't it? Because small t will go this side. So be very careful. If they are asking you to talk, if they are asking you to find the value of rate of heat transfer, you should find H, which is Q by T. If they are asking you to find the heat transferred, you should use Q, which is equal to Ka delta T into small t by L, where delta T is change in temperature and small t is time. Is it clear to you? And this K, it gives us an idea about how fast the heat gets transferred. An object having higher K, the rate of heat transfer will be more faster. An object having lesser K, the amount of heat transfer will be very low. And from here you can also find its unit. If I want to find what is the unit of K, I can find, because K will become equal to Q into length divided by K into A into delta T into small t. So you can see very clearly from here, if it is in joules and length is in meters, divided by, why I am writing K here? K only I am finding. So A is in meter square, delta T will be in Kelvin and T will be in seconds. So if I cut this, it will become joule, meter inverse, Kelvin inverse, second inverse. Are you getting? This is the SI unit of what? SI unit of K. This also comes in the examination. What is the SI unit of K? I'll write, I have mentioned here also, see. Joule per second, per meter, per Kelvin. Sometimes they are asking you to find or write what is the SI unit of K, and the answer is joule per second, per meter, per Kelvin. And as I said to you, greater the value of K, the greater is the transfer of heat, that is more rapidly transfers the heat. You know which material has the highest, relatively, what we are using generally? If you have silver, aluminium and copper, which material do you think will have more K? Copper, silver.
Aluminium, sir.
No, aluminum has least in these three, silver has the most. If you keep things in silver, then it will have a greater rate of heat transfer. But it is like ornament silver, so we don't use it generally. Some rich homes, they are using silver for vessels also, for your information. But generally we are using copper in some homes. Copper, if you use, it will have a better rate of heat transfer. So I have drawn some chart which indicates the material's conductivity, and you can see silver has 406 K, copper has 385, good only copper also, aluminum 205 and so on. And you see air has very less, air is a good insulator. Air has very less, 0.024 as the value of K. So if the question comes, you can very clearly indicate that air is an insulator. Air is an insulator, it never allows heat to transfer through it, like because its conductivity is too low, 0.02. Are you able to feel it? And in that way copper is having very good conductivity, not only in terms of heat, later you will study in terms of electricity also. That's why you are using copper wires, isn't it? So these are mostly metals, non-metals and gases. So that's the reason I told before some time that why some cooking pots have copper coating at the bottom, because it will have a better heat transfer, rate of heat transfer, and it will distribute the heat evenly in the bottom of the pot. So when you cook something, the heat gets distributed equally in all the parts and you can cook better and you can have a better cooking. That's why if you go and buy vessels, they will say copper bottom. They are selling by saying copper bottom. Why they are saying copper bottom? Because if it is copper bottom, the heat will be transferred equally and you will have a better cooking of the food. Other some part of the food will not be uncooked, it will be like that. So something like that you can imagine. Fine. I hope it is clear to you. The formula is clear to you. The Q by T, which is equal to K into A into delta T by L. Let us try to take some numerical. Okay, after convection we will take. So what is convection? Write the definition. All of you please write a definition. What is convection? Convection is a mode of heat transfer by actual motion of the matter. It is the mode of heat transfer by the actual motion of the particles. And we don't observe convection in solids. It is observed only in fluids. I should not say liquids, I should say fluids. So convection is usually visible in fluids. So the best example is boiling of water, where what happens? The hot water becomes less denser and rises up, and the cold water goes down as it is heavier, so it comes down. Okay. So as I said, convection is a natural phenomena, and the land breeze, the sea breeze, all these things are due to the convection principle only. I hope you are aware about this. That what is a sea breeze? During daytime, what happens? During daytime, the sun is heating the earth's surface. In that, we have some land part and some water part. So in the case of, now, solids will have more K value, isn't it? Liquids had less K value, gas has least K value. So since the land had more K value, it will heat up quickly. Since the heats up quickly, it will have the warm air, it will rise up. And since liquids have less K, it will be relatively cooler. So it will have, cool air. So what will happen? I said you, warm air is lighter, it rises up, and the cool air is heavier. It starts rushing towards the land, where the space is made empty by warm air. So the air becoming warm rises up. Here the air being cool rushes towards the land, and this is called as what breeze? What breeze is called as? Sea breeze. So why sea breeze cools us? Because even if daytime you go to beach, you can feel some kind of air coming to you. Even if it is a hot day, you can feel some air is coming to you. Why that air comes? Cool air comes because from sea the cool breeze comes towards the land. And during night what happens? If it becomes night, then since it has more K, which land has more K, solid has more K, it also cools quickly. If it cools quickly, it is having cold air now, and water cools slowly. It is relatively warmer. So now this water will rise up and this will rush towards the sea. This is called as land breeze. Are you getting my point? So in this case, the air will flow towards the sea. In that case, the air will flow towards the land. This phenomena also is purely because of convection. Land breeze, sea breeze is also because of convection. Air rising up and making space for the cooler air to come inside. Right? Fine. Now we are entering into one important topic after discussing about conduction and convection. Now we are going to talk about one of the most important part of today's lecture, which is radiation. So what is radiation? It is a mode of heat transfer without actual movement of source or target, and also without heating the intervening medium. Please note it down. Please note it down. The definition of radiation is there. It is a mode of heat transfer without the actual movement of source or the receiver, without heating the intervening medium. Without heating the intervening medium. I hope you have written. So those who were aware about this radiation, I would like to ask question to everybody who is there in the online and as well as offline, that yes, as I am showing to you, sun is there, hot sun, heating the earth, but the medium between earth and sun is not heated. Why?
No medium, right?
Vacuum, sir.
Okay,
That's
okay,
vacuum, right?
okay, very good. If there is no medium, then how is the heat getting transferred?
Through waves, sir.
Through
Waves.
which waves, Ivan Shankar? Longitudinal waves or transverse waves? Some waves. Good, good, good try. Anybody else who can comment on this?
Through
Yes.
the light rays. Through the light rays.
Through the light rays. So, do you think that light rays don't need any medium to travel? It will travel without any medium. You are thinking like that. Photons have?
The photons, sir. Photons emitted by the sun, they carry the heat.
Oh, so you think that sun is having photons inside it, that photons is carrying the heat, but when it is moving, it won't heat the, like what is there between earth and sun, and when it comes to earth, it starts heating the atmosphere of the earth, right?
Because there is nothing to heat it there, sir. There's vacuum, so there's nothing to heat it.
Okay, so
So, but Earth is a weak.
photons need no medium to travel, isn't it? As per you, am I right, Abhinand? Yes, yes, good try, good try, good try, good try. I'm not saying you're wrong or you're right. Good try. Is my question clear to you? Sun is hot, heating the earth, earth becomes hot, in middle nothing becomes hot. It means the heat energy has transferred without a medium, that's for sure. Now understand what has happened. This topic is there in 12th standard. One chapter is there in 12th standard. Chapter name itself is electromagnetic wave. Okay? Light is an electromagnetic wave. You will learn in higher class, that is in 12th standard. Up to now, you know about two kinds of waves. One wave is called as longitudinal wave, another wave is called as transverse wave. Both of them are a part of mechanical wave. And mechanical waves are those waves which need material medium to travel. So, transverse waves also needs medium to travel. Transverse waves travel on the surface of the medium, whereas longitudinal wave travel inside the medium. When I am speaking to you, you are able to hear me because my sound, that is from my mouth, what is created by my vibration of my throat, that is reaching you because of the medium between you and me. If this medium is not there, you cannot hear me. If the medium between you and me is not there, you cannot hear me. Here, what is moving? Longitudinal waves is moving. On the sea, you should have seen some waves coming, right? Those waves are transverse waves. So, transverse waves are on the surface of the liquid. Imagine tsunami has come. How tsunami comes? Inside the sea water body, there is some kind of tectonic plate movement. Tectonic plate has moved. Then there is some waves produced. Those waves are longitudinal waves. They are traveling towards the surface. When it comes to surface, it becomes transverse and becomes huge waves which can cause destruction. These are mechanical waves, right? Which needs medium to travel. Many children think that light is a transverse wave. No, light is not a transverse wave. Light is a different, special kind of wave, which was found by whom you know? Maxwell, a scientist named as Maxwell. He found that light is an electromagnetic wave. An electromagnetic wave needs no medium to travel. It can travel without a medium. Electromagnetic wave, how it is formed? It is formed by accelerating charged particle. Remember this in your mind. Electromagnetic wave source is accelerating charged particle. It means if you have sun burning, if a charged particle is accelerated, then we will have something like this produced. First, yes, we will have electric field and magnetic field which are oscillating perpendicular to each other. These things will come in 12th only, not required for 11th. Just for your knowledge, I am telling you, electromagnetic waves are formed when the electric field and the magnetic field are oscillating perpendicular to each other and the motion of the wave is perpendicular to both of them. You can see x axis is the direction where the wave is moving, and electric field is vibrating in the this xy plane, isn't it? And the magnetic field is vibrating in xz plane. Are you able to feel it? How it is vibrating? Vibrating in this plane. blue line up and down, and the wave is moving in this direction. That is how the electromagnetic wave moves. Now, electromagnetic wave has lot of spectrum inside it: ultraviolet, visible, infrared, X-rays, radio waves, microwaves, and all these things. All these waves are there in what? Electromagnetic wave. So, from the sun, when the electromagnetic wave is produced, all these spectrums are produced. And you know, on the earth, the spectrum reaches. So, heat on the earth is not because of the heat of the sun. Actually, it is because of the infrared waves that has reached your surface. Understand that first. What is heating the earth's surface? The infrared waves coming along with the electromagnetic wave of the sun. Are you getting my point? I will give an example to you. Suppose you have apple, okay, generally red in color until it is rotten. Generally apple is red in color, am I right? So, if you have apple, why it looks red to you? Any idea? If an apple you are seeing and it looks red to you, why it looks red? Because it is naturally red. Is it because of that? You think because God has made it red.
The light reflected by the apple is red.
What is the meaning of it? Light reflected by the apple is red.
No, it actually reflects all other colors except for the color red.
Oh, so he thinks that it reflects all the lights and not red light, so it is looking red. Am I right, Anshul?
Yes.
Okay, you may think like that. Good. Others, anything? Why apple looks red? Why orange looks orange? Why mango looks yellow? Because whenever, understand this first, please be very clear in this phenomena. Today I am going to teach you radiation, and it all requires you to understand these things. Whenever the light ray is falling on an object, it has two possibilities. One is absorption, other is reflection. What it reflects, that it looks like. So, apple looks red because when the light ray is falling on it, it is reflecting red color to you, and all the other spectrum is getting absorbed by this light. Are you understanding what I am trying to tell you? When the light ray is falling, I told light is the electromagnetic wave. Electromagnetic wave falls on this. Out of all the rays it has, red is coming to you. Everything else is absorbed by it. That's why it looks which color? Red color. Mango looks yellow because it will emit only, not emit, it will reflect only yellow color. Other things will get absorbed. So it looks yellow to you. If something is black, it means what? It absorbs everything and reflects nothing. If it absorbs everything and reflects nothing, it is called as black. It looks black to you. That's the reason in summer we prefer to wear light color clothes, because light color clothes will reflect almost everything and absorbs nothing. If it is looking white, it means what? White means it is reflecting all the colors. That's why it looks white. See, white is combination of all the colors, right? Violet, indigo, blue, green, yellow, orange, red combinedly becomes white. Something is looking white to you, it means it is reflecting everything. And if something is looking a particular color to you, it is reflecting only that color to you. If something is looking black, it means it is not reflecting anything. So in colder days, we prefer to wear black, dark colored clothes, because whatever sun rays are coming, it will be absorbed by us. And in the hotter days, we prefer to wear light color clothes, because it will reflect all the rays coming on it. Now, see, one more thing, important thing is, when the light ray is falling, that is when the electromagnetic wave is falling on an object, the object becomes hot. Have you felt it? Keep an apple in the sun. Don't you think apple will become hot in some time? Becomes hot, right? Why? Sun is heating. Huh?
Because of the radiation that have observed other than red.
Exactly. Because it is absorbing the electromagnetic wave, which is energy. Red is reflected, other things are getting absorbed. Now my question to you, Pratap, is if it is absorbing, If apple is kept in sun for 2 hours, will apple start burning?
Not possible, sir.
Why? It is absorbing, no? Will it become too hot that you cannot touch it?
Sir, there's, I think, there's
Limit.
another phenomenon known as transition.
Okay, what is that?
Which I'm not so sure, sir.
Okay, anybody else?
That might help not burning something.
Okay, okay. Anybody can tell me what question I've asked, can you reply for it? My question is, if light is continuously falling on the apple, will apple become too hot to touch? But energies keep on going inside it? Then it's as per you.
So apple may look fake, sir.
So why apple is fading? Because it's absorbing too much light, so it becomes too hot. Am I right, Ivan, as per you? No. Whenever a body absorbs some radiation, it not only absorbs, it emits also. You know why? Because when it absorbs radiation, its particles start vibrating. Particle is vibrating, particle is becoming accelerated charge. Accelerated charge produces electromagnetic wave. So electromagnetic wave will start getting reflected also. You may think that why I am not able to see it. Why you will see it? It will not be lying in the visible range itself. Infrared waves can you see? You cannot. You know our human body is always emitting some heat. Are you aware about this? Am I able to see it? No. But if I put an infrared camera here, I can see red. Everything is red. You know why? Because you are emitting infrared waves always if you are in light. If you are in dark, you may not. But if you are in light, absorbing radiation, emitting radiation. Are you getting my point? That's why that infrared camera captures heat. Are you understanding this? What is infrared camera? It captures heat, right? Even thermometer is made by that principle. Nowadays we have thermometer. They'll put on your hand or head and they will tell how much temperature you have. How? They are converting the wavelength that you are emitting into temperature and finding how much temperature you are. Please understand all these things today. That every object, after absorbing what light is falling on it, emits something. So suppose apple case, if I once again tell, apple absorbed electromagnetic waves, already reflected some part in terms of red color, and remaining energy also started reflecting slowly because of the, as I said you, excitation of electron inside, it emits. That's why it is not becoming too hot. Are you understanding? Because what energy it absorbs, everything it is not keeping inside it. It is emitting also. So one side absorbing, one side emitting. So it maintains a thermal equilibrium. Are you understanding it? Heat is one, radiation is absorbed, radiation is emitted, it maintains a thermal equilibrium. Now the body will have no further absorption, or it will absorb, emit, absorb, emit, absorb, emit. It will not have temperature rise, reached maximum temperature. Are you getting? If it becomes too hot, it will start emitting radiations which may be visible to you. That's why if we are making, like for example metallic, you have an iron box is there, heating it, making it too hot, it will start giving colors to you, right? Yellowish color it will give, burning, reddish color it will give, whitish color it will give, blue it will give. You know why it is giving that color to you? Why it is glowing? Because now it is emitting electromagnetic radiation of visible range. If you have a body at 50 degrees Celsius, it may not glow. Why it will not glow? Because it is emitting, but emitting infrared radiation. See, first you should be very clear. The order of wavelength is, for the longest wavelength is of infrared, then you will have visible range, then you will have ultraviolet. Ultraviolet has least wavelength and infrared has maximum wavelength. In middle we have that Vibgyor, that visible range, violet, indigo, blue, green, yellow, orange, red. I hope you know these basic things. So, as temperature of an object is increased, the graph shift towards, from infrared shifting towards visible, and so you are able to see it, see the glow of something. Now this idea only made people to start understanding the temperature of the stars by seeing its color. If I am saying some star is at this much kelvins, do you think I have gone there and checked and came back? No, right? How we are putting that estimate then? Just because of radiation. And there is something called as black body radiation. You know why it is that? What is black body? Black body means an object which absorbs everything and reflects nothing. If it absorbs everything and just does the electromagnetic radiation emission and not any other reflection, it is the perfect thing to understand the color of that is any spectrum. That's why we are studying about black body radiations. So we'll come to that. First, let us also understand thermal radiation. I said you electromagnetic radiation emitted by a body by virtue of its temperature is called thermal radiation. So if you see something looks reddish in color, why is it looks reddish in color? It would have attained the temperature where the wavelength of the light would have come in the visible range. So it is able to look as reddish in color. This light from a filament bulb. These are the examples of this thing. Now you see, whenever the sun rays are falling on the earth, right? When the rays are falling on the earth, it is partly reflected and partly absorbed. When it is partly absorbed, then see one thing, amount of heat that a body can absorb by radiation depends upon the color of the body. Which body will absorb the maximum radiation? Black body, isn't it? So black bodies absorb and emit radiant energy better than the bodies of lighter colors. Maybe if you take a perfect black body, it will have the maximum absorption and the maximum emission. Are you understanding my point? That's why we wear white or light colored clothes in summer and dark color clothes in winter, because in winter you will have to keep your body warm. If you are wearing a dark color cloth, it will keep your body warm. Tell me one. Yeah, one second, Sugindran. Yes, tell me.
That's why the tar roads also experience that much hotness during summer also.
Obviously, yes, because it is black in color, it will have too much of heat.
Oh, okay.
Yes, tell me,
Sir,
Sharan.
you told that when body becomes too hot, radiation moves from the infrared to visible range.
Yes.
Then if the body becomes even hotter, then from visible range it will move to
Ultraviolet. Yes, true. We'll talk about it now. Okay. So now let us see the most interesting part. So one more example is thermos bottle. Have you seen thermos bottle? Thermos bottle means that flask that you are using for keeping the water hot. You know what is the phenomena inside thermos? You are thinking, okay, something they are making some insulation, that's why it is hot. Main thing is radiation here. So we have double walled glass vessel, and if you see between the inner wall and outer wall there will be some vacuum, which will make sure that whatever heat radiation takes place, it remains inside the vessel and keeps the water warm, or whatever there is there inside. And outer radiations are not allowed to enter inside, it will be getting reflected, because the space between the inner part and outer part is kind of vacuum, and your particular liquid inside the flask remains hot for a longer time. That's how a thermos bottle is made. But again, today our topic of interest is this, where we are going to understand, see this, raise the temperature of the source, describe a change in color of the source, describe a change in shape of the graph, how does the wavelength of maximum intensity change. So now we are going to study about this part. Be attentive now. We have come to the most important part of the day, where if you are understanding, you will be very clearly understanding the colors and which is hot, which is cold, stars and all these things. So here I have drawn spectra for you. Can you feel the x-axis? It has wavelength. Understand that this is the visible spectra, and what is this? Infrared, and before it ultraviolet. Am I right? So when we are taking a lesser temperature, for example, if we are considering something like a temperature of 30-40 degree, then you can see the graph forms like this. The peak is somewhere here. If the peak is somewhere here, then it is almost infrared, it will have no color visible to you outside. And if you see, as temperature is rising, what is happening? The wave is shifting its graph to this particular point. So if you come to this particular point, you can understand that it will be in white in color. You know why white in color? because it is releasing all spectra. If it is releasing all the spectra, then it will look white to you. Mixture of violet, indigo, blue, green, yellow, orange, it becomes white. And if I further increase, it shifts its focus towards more left. If it is shifting towards more left, what is there in more left? Blue light is there. If it is blue light, then you will be able to have more blue visible to you. It means if you are seeing something blue in color, it is more hotter. White in color, little less hotter. Yellowish in color, further more less hotter. Are you getting my point? Red, white and blue. I asked this question in the beginning today. Red is the coldest comparatively. Blue is the hottest comparatively. Because at higher temperatures, the wavelength of light becomes less. And violet color has a lesser wavelength compared to what? Compared to a red light. Are you getting my point? So you can see, please ask me.
Sir, I think it's kind of silly, sir, but in gas stoves, fire is blue in color.
Yes.
Does that have to do anything with the temperature of the...
Obviously it will have. If you see a bluish flame and a yellowish flame, the bluish flame will have higher temperature compared to a yellowish flame. Are you getting my point?
Yes, I thought it was with the gas, not because of the...
Not like that. It is because of radiation. See, anything that you are seeing, no, whatever color, if something is looking green to you, yellow to you, blue to you, everything is because of radiation and reflection, nothing else. Understanding, Abhinand? So what we come to know today? We come to know that wavelength of the light can be helping you to understand its temperature also. If you are seeing something very far and it is bluish in color, that is, I am talking about the stars, understand it is at very, very high temperatures. And if it is reddish in color, understand it will be at relatively lesser temperatures. Are you getting why? Because if something is like, for example, at temperature 20 degrees Celsius, if I am once again explaining this to you, give me a second. Yes. So I want to add some points here. That is, if temperature is lower, then the graph forms something like this. I'll take some other color. Yes. If the graph something forms like this, for example, I am taking temperature as 20 degrees Celsius. Okay. Now, if the graph is somewhere here, what is the wavelength mostly? Infrared. Will it be visible to you? No. You can, if you want to see this wavelength, you have to use infrared cameras. If you are having infrared cameras, you can see something. You can see that infrared waves through it. Temperature increased to suppose 500 degrees Celsius. Right? You know what will happen? The graph will move like this. Now you see, infrared is there. What also has come now? This range has come. And more of what has come? Red has come. It look reddish in color. I go more, 600 degrees Celsius. It may move little more this side. Then it will show some kind of yellowish to you. Are you feeling it? If I am having temperature as 3000 degrees Celsius, then the graph may go like this, where you will have more of all the waves. It will look white in color. And if temperature goes 10,000 degrees Celsius, it will start moving towards this now. Are you feeling it? And so you will have more of bluish shade and it will look blue to you. Are you getting what I am trying to say? These numbers are just for explaining you, not realistic numbers, just to make you understand that as temperature is rising, the wavelength is reducing. Understanding it? So if an object is radiating ultraviolet wave, it is at very, very high temperature. Understanding? If you heat a body too much, it will start emitting ultraviolet wave itself. And if ultraviolet waves are getting reflected by the body, not reflected, emitted by the body, understand that the body is at too high temperature. Understanding this, if it is clear to you, then what we came to know? We came to know that the source gets bluer, the graph is taller at all the wavelengths. I mean, whatever I have talked, same thing they have written here. So I have drawn some graph to make you understand, like sunlight graph, arc, that is what we are using for welding and all, and is a lamp filament. So see, lamp filament, earlier we used to have tungsten bulbs, now we have LEDs and all these things. Earlier we used to have tungsten bulb. Why we replaced it, you know? Why did
More
we,
energy consumption, sir.
why more energy consumption?
But to make it emit visible spectrum light radiation, we need to give it more energy, sir. Tungsten can absorb more energy, sir.
Okay, one more way we can say, if you have some reflection here, many emission will be from infrared spectrum, right, Akhilesh? Since many emission is from infrared spectrum, it will not give you any benefit, just heat it will give you. And we want light from the bulb, isn't it? We are not using bulb for cooking food, we are using bulb for seeing. What we need? Visible spectrum. But because of tungsten bulb, what you are getting more? Infrared spectrum. So it was consuming more power because much of the energy was lost in giving you infrared spectrum. Are you able to understand this? It's very important what I have told now, right? So now you can write this. It's very important, which is, give the heading as Wien's displacement law. What I am teaching now is Wien's displacement law. Wien is W-E-I-N, Wien. W-E-I-N, Wien. Wien's displacement law. This law relates the wavelength of light with the temperature. This law relates the wavelength of light with the temperature. So what I said before some time, the same thing I am repeating now. I said that wavelength, that is lambda, is proportional to, inversely proportional to temperature. Am I right? If temperature becomes more, lambda becomes less. Tell me, Sugindran.
This law relates wavelength of light with what, sir?
Temperature. So lambda will become equal to constant times 1 by T. This constant is called as Wien's constant. B is called as Wien's constant. It has a value. I will tell the value also to you. So you can write from here lambda into T is equal to B. This also you can write. This is called as Wien's displacement law. Lambda is the wavelength of the light emitted by the body. T is the temperature. So as per black body radiation concept, the wavelength of the radiation, emitted radiation, is inversely proportional to temperature of the body. Are you clear in this? Same thing they would have written here also, whatever I have told now. Lambda into T is equal to B. Same thing I wrote. Wien's constant B has a value of, write it down, 2.9 into 10 to the power minus 3 millikelvin. 2.9 into 10 to the power minus 3, not millikelvin, meter Kelvin. Meter Kelvin. M is meter, K is Kelvin. Is it clear to you? You may get numericals from here. You know how the numericals will come? It will come like, if 200 degrees Celsius is emitting light of this much wavelength, 600 degrees Celsius will emit light of how much wavelength? Are you getting how the question will come? Numerical will come like, if temperature is equal to 300 degrees Celsius, lambda of, this is something, 3034, right? Anything you write. And then they will ask, if T becomes 400, what is the lambda? How will you solve? You know that lambda is,
Each constant will be constant.
yes,
So you'll find lambda by that.
lambda 1 by lambda 2 is equal to T2 by T1, isn't it?
Yes.
You have the value of lambda 1, you have the value of T1, T2, find lambda 2. Easy, right?
The
Not-
famous modulus.
You not to solve now, I was telling you. This kind of questions are coming. Is it clear to you how the questions are coming? Right. So, same thing what I wrote here, see, the color of piece of iron heated in hot flame first becomes dull red, then reddish yellow, and finally white hot, isn't it? That's what is the order of heating. Check if you want to check also in welding and all. So, first it will be red hot, that is the dull red, and then it will become yellowish, and then it will become whitish, and after white what will become? Blue. Blue K means it is too hot, right? And this law is useful for estimating the surface temperature of celestial bodies like moon, sun and other stars. So, as I said to you, this question now everybody can answer, I think. Red and blue, which is more hot? Blue. Obviously more blue. Obviously blue star, isn't it? Because of lambda inversely proportional to temperature. Lambda is less of red, so it is at, sorry, lambda is less of blue, so it is at higher temperature. Lambda is more for red, it is at lower temperature, isn't it? So, just by knowing the wavelength, now you can tell whether it is a more temperature or less temperature. I hope you are understanding this. Next comes the Stefan-Boltzmann law, right? Stefan-Boltzmann law. Next topic is Stefan-Boltzmann law. Stefan-Boltzmann law. This law talks about the energy emitted per unit time, and you write heat energy emitted per unit time. Again, H is Q by T, don't forget that. H is always what by what? Q by T. So, this is equal to A into sigma into T power 4, where sigma is the Boltzmann constant, Stefan-Boltzmann constant. I will talk about that also now. So, Q will become equal to sigma into A into T power 4 multiplied by small t. This is called as Stefan-Boltzmann law, where for a perfect radiator body or black body, for a perfect black body, energy emitted per unit time is equal to A, which is the surface area, T is the absolute temperature, and sigma is the constant. A is the area of the body, T is the absolute temperature, and sigma is Stefan-Boltzmann constant. Its value is 5.67 10 to the power minus 8 watt per meter square, Kelvin power minus 4. Energy by time is watt, that's why they have used the value of watt. Work done per unit time is power, right? That's why they have used the value of unit as watt. Did you write this? We will have some numericals now from this law.
Just a second, I can copy.
Make it fast. Can I proceed, Abhinand?
Yes, sir, you can.
Okay. So, one more thing I will tell you. I said that whenever a body is absorbing some energy, it is not emitting everything that it absorbs. So, how much it emits, that is called as emissivity. So, what is emissivity? Emissivity is the fraction of the radiation that an object emits after absorption. It is given by the letter small e. Are you understanding? If emissivity is 0.4, it means only 40% of the radiation which it absorbed, it will emit. If the emissivity is 1, it means perfect black body it is, which will be having full emission. Whatever it absorbs, fully it emits. It is only theoretical, ideal, not happens in real time. Are you getting the meaning of emissivity? Emissivity means what is the proportion, what is the fraction of energy of what it absorbed, it is going to emit. If it is going to emit all of its energy absorbed, it will become a perfect black body whose emissivity, I wrote emissivity, actually it is emissivity, sorry, it's a mistake in the spelling. I will write once again, MECVT. MECVT, it is not MECT, MECVT, small e. MECVT is the fraction of the energy which it emits outside. Okay. So, if I put the value of emissivity here, then H will become equal to E into A into sigma T power 4, isn't it? How much part it wants to emit outside, it is given by emissivity. So, generally they will put the E value with this H to find how much exact amount of energy it emitted outside. Is it clear? And all these things, whatever I have derived, whatever I have told now, is based upon the assumption that there is no other temperature of the outside surrounding. If we take into consideration that factor also, then you see, a body at temperature T with surrounding at temperature Ts emits as well as receives energy. So, in that case, the formula of H will become, already we had the formula of H as what? H formula was E into sigma into T power, sigma A into T power 4, am I right? This was the heat energy emitted. It will absorb some heat also. So, overall net heat what it is going to emit will become equal to E sigma A T power 4 by Ts power 4, where Ts will become temperature of surrounding, temperature of surrounding. Is it clear to you? Can I proceed? I hope you have written this. Have you? Can I proceed further, guys?
Yes, sir.
Yes, sir.
Take a question then, fast. Don't take much time. 3 minutes timer, please. The question is in front of you and you have 3 minutes to solve this. Simple question, give a try. They have given the temperature, emissivity as 0.5, surface area they are asking you to find, power is given of the bulb and heat loss is negligible. Sigma also is given to you. So, just put in the formula, get the answer, make it fast. Last 1 minute. If anybody has got the answer, you can say. seconds. Make it fast. Anybody has got it? That formula based question. Yeah, if you multiply everything properly, you'll get the answer. 1 by 360 centimeter square. Let us check. Anybody else? Time is up. Time is up. Let us see what they have given. Temperature as 3160 Kelvin. MEC is given as 28 watt. Am I right? What is the formula we have? Formula is sigma into E A power A into T power 4. Value of sigma they gave us 5.10 power minus 8. Value of A 5. T is 3160. Am I right? Just this was the calculation. If you do it properly, you will get the answer. If you solve it, you will get the A value as approximately 10 to the power minus 5 meter square. Also, if you convert, it will become 0.1 centimeter square. 3160 power 4. Yes, you should. 3160, 3160, 3160, 3160. You are in 11th now. So, yes, may happen. So, 316, 316, 316, 316. 4 times. The answer is approximately 10 to the power minus 5, which is 0. Okay. I think question was simple, only the calculation. I agree with you, but you have to spend time. No other option you have. In such a way that you can solve it easily. But here they gave 316 random question. So they gave the value like that. I hope you are understanding this. Is it clear to you? I hope it is. If yes, the last topic and sleep. The last topic of the day, which is Newton's law of cooling. Give the heading as Newton's law of cooling. Newton's law of cooling. Okay. So I'll ask a question to everybody. You can answer, or I'll point and then you answer. This question is for Niranjan TMR. Okay. There are 2 Niranjans there, 1 Niranjan. Yes, you are able to hear me, Niranjan?
Yes, sir.
Yeah. So you tell me, if you have a hot coffee in your hand, okay, and you are in summer month, after some time the coffee will become cold if you don't drink it. Do you agree?
Yes, sir.
Obviously, it will become.
Yes, sir.
Next thing is the same coffee, the same temperature, but now you are in winter season. Once again, it will become cool, right?
So the time difference would be.
More in which case?
It will get cold so faster.
Okay, in winter it will be cooling more faster, in summer it will be cooling slower. Am I right?
Yes, sir.
Do you agree with it, everybody in the meeting? He says that in winter season, his coffee is becoming colder sooner. In hotter season, it becomes like it is cooling little slowly. Everybody in the meeting agree to this? Obviously, yes, I also agree with him. Nobody should have an objection. Mumesh, no objection, no?
No, sir.
Okay, Mumesh, thank you for your consent. So, Newton's law of cooling is the same thing. It says that rate at which a body is losing heat is directly proportional to temperature difference between the system and the surrounding. It means that the coffee is at 70 degree, outside temperature is 40 degree. What is the difference in temperature? 70 minus 40, 30. If coffee is at 70 degree, outside 20 degree, what is the temperature difference? 50. So if temperature difference is bigger, the cooling will be faster. If temperature difference is smaller, the cooling will also be slower. Are you getting? Write this statement. It says that the rate of cooling of a body is directly proportional directly proportional to the temperature difference between system and surroundings. To the temperature difference between system and surrounding. Is it clear to you? That is the definition of Newton's law of cooling. So as per the statement, as I told you, minus dq by dt is proportional to delta T. Why minus is there? Because the body is losing heat. That's why minus sign is there. dq by dt is the rate at which the heat is lost. Negative sign indicates that the body is losing heat. I hope you are understanding this. Why is negative sign is there? It indicates body is losing heat. I hope it is clear. Now, not going to end here. The statement was given by Newton that minus dq by dt is proportional to delta T. Abhinand, be ready. Lot of math is going to come now. Okay? Pure science student, you should concentrate more now. So now what happens, you see. So I can write minus dq by dt is equal to T2 minus T1, and I am putting a constant k, right? Nothing big I have done. I have put the constant as k. K is a positive constant obviously, and value of k depends upon what? It depends upon two things: area of the surface of the body, nature of the surface of the body. You can write this down. Sometimes they may ask you a question on which factors k depends. K depends upon two things. One is area of the surface, second is nature of the surface, whether it is more conducting, less conducting, it depends upon that also. If you are having a iron losing heat or coffee losing heat or water losing heat, it also plays an important role. Which kind of liquid, which kind of solid you are cooling down. And second is area. Obviously it depends upon the area. If you spread the water for more area, it will cool faster, isn't it? Same coffee thrown on the floor, hot or cold, whatever day it may be, it will immediately become cool. Because area became too bigger, it will cool faster, isn't it? So it depends upon these two things. Is it clear? So we came to know that minus dq by dt is equal to k times, which is a constant, T2 minus T1. Up to here it is clear. Can I change the slide? Can I? I will.
Yes, sir.
Yes. So if temperature of the body falls by a small amount dt in time dt, then I can say that loss of heat by our previous classes, calorimetry, Q is equal to mc delta T, remember? So if I write dt divided by dt, that is dt, I am talking about time now, you got the value of dq as mc delta T. If I find dq by dt, that will become equal to mc dt by dt. Do you agree? Same thing would have been written here also, see. dq by dt will become mc dt by dt. And in the previous page, we found that dq by dt is equal to k times of T2 minus T1. I will write both now. So I will equate the right hand side. If I equate, I will get mc dt by dt as negative of k times of T2 minus T1. Do you agree with me? Now the integration starts. Shall I proceed further? Okay. So next is dt by dt will become equal to minus k, mc comes down, T2 minus T1. And then if you see, first I will let them copy. First copy this, copy up to here. Let me know if you have copied. It's a 3-mark question for the school examination. Derive Newton's law of cooling. Derivation is 3 marks question in the school examination. And simple derivation, believe me if you understand this. dt by dt came as minus k by mc into T2 minus T1. All of you have copied? Let me know if you have copied.
Yes, sir.
Can I go to the next page?
Yes, sir. Yes, sir.
Okay, thank you. So then what I will do, I will take this k by mc there, no? Full k by mc I will take it as a constant, which I am taking it as capital A. So my dt by dt will become equal to negative of capital K, or I will bring this t2 minus t1 down and will make dt2 go that side. So dt by t2 minus t1 become negative of k dt. Is it clear what I have done? After that, I will integrate both sides. On the right hand side, we have time. I will put the limits of time. On the left hand side, I have temperature. I will put the limits of temperature. Can I? So I am going to integrate both sides. So integration of dt by t2 minus t1 into negative of k dt. When I integrate, what is 1 by x dx? This is not d2 here, okay? Don't confuse, it's not d2. So what is integration of 1 by x dx, guys? Those who are knowing it.
Log dx.
Log?
Log t2 minus t1.
Which log?
x2 minus x1. Natural log.
Not log. What is this, man? Integration of, huh? Log? Log e only, log base e. Log base e into x. Log base e is only called as ln also, isn't it? Ln x. I hope you know this. Those who are knowing, d by dx of log x is how much? 1 by x. So integration of 1 by x will be how much? Log x. Understanding this? All of you who are there in the class are understanding it? So from that logic only this has come. If you are seeing this here, how suddenly ln came? 1 by, you have 1 by x dx. So 1 by x will become ln x. So ln t2 minus t1, and here minus integration of t will become, dt will become t, and they are adding plus c as a constant. I hope you know that whenever we integrate, we add a constant plus c. That's why we have put plus c here. That much integration I hope you know. After that, what I will do? Now I'll start using logarithm principles. So log a is equal to b, a will become equal to e power b. You know this? Those who know log. If log a is equal to b, a will become equal to what power what? If it is log e, then it will become e power b. You know this? This property of log is known to you. That only I am going to use now.
Yes, sir.
Yes, so I am going to use now ln t2 minus t1 is there, no? So I will write t2 minus t1 as e power minus kt plus c, right? So from here I will get the value of t2 as t1 plus this c into e minus kt. You know what is this? I will tell you what they have done. One step they have skipped, I will write it for you. Some of you will get confused. They are writing this as e power minus kt into e power c. Can I write like this? Because powers are getting added, and e power c they have taken another constant capital C. So they are writing t2 is equal to t1 plus c into e power minus kt alone. Is it clear what I have done? Is it clear to you? They are breaking this minus kt plus c as e power minus kt into e power c. This e power c they are taking as a constant capital C. So finally we got t2 is equal to t1 plus c times e power minus kt. Is it clear to you? This is Newton's law of cooling. Is it fine? Those who are there in the online class, I hope you have understood. Have you?
Yes, sir.
This is about conduction, convection and radiation. Conduction is that mode of heat transfer where the energy gets transferred from one point to another point without the actual transfer of molecules. Rate of heat transfer by conduction, H, which is equal to Q by T, is equal to A into T1 minus T2 into delta T by L. Am I right? That was the formula of heat transfer, that is rate of heat transfer, Q by T. And then we have spoken about convection, which is a phenomena where the heat gets transferred by the actual transfer of molecules. We see it mostly in fluids. Even the land breeze and sea breeze are the phenomena because of convection only. Then we learned about radiation, where we spoke about black body radiation. I said radiation is a phenomena where a body emits energy. And why it emits energy? After absorbing energy, the particles of the body starts vibrating, it will start emitting electromagnetic waves, and those emissions are coming out as infrared radiation or visible radiation or ultraviolet radiation. If it is infrared radiation, you cannot see by naked eyes, but if it is visible radiation, you can see by naked eyes. That's why hot things have some color. If it becomes very hot, it will have yellowish color, reddish color, whitish color, bluish color. It's all because of spectrum that the object is emitting and what you are seeing, right? So after radiation, we talked about Wein's displacement law, which says that lambda is inversely proportional to temperature. More temperature, less wavelength, less temperature, more wavelength. And we learned about Stefan-Boltzmann law, where it talked about how much heat energy is emitted per unit time, Q by T. And the formula was, if I talk emissivity also, E times of sigma into A temperature power 4. If surrounding is involved, then it will become E into sigma into A T power 4 minus T of surrounding power 4. Right? Very, very, very important for competitive examination. Even if you are not minding for school exam, Stefan-Boltzmann law, Wein's displacement law, very important for competitive examination. Right? Then comes the last topic, Newton's law of cooling, where you understood that the rate at which the body is losing heat, it is getting cooled, is depending upon the temperature difference between system and surrounding. And we derived what is the formula of T2. T2 will become equal to T1 plus C into e power minus kT. The statement is minus dq by dt is proportional to delta T. When we derive from there, we get the final temperature T2 is equal to T1 in T1 plus C power C into e power minus kT, right? So with this, we come to an end of this chapter. Next class, I am going to start talking about thermodynamics in this class. This class will go in the order only. After thermal properties of matter, thermodynamics, kinetic theory of gases, oscillation waves. But in the offline section, I will be talking to you about oscillations in the next class. Okay. So with this, I am ending my class, and we will meet once again on the next class.